Let me share my screen. Actually, I'm not able to share my screen.
Oh, okay. 1 second. You can try again.
Yeah. One second. Is it visible?
Yes, you can see your screen.
Okay. So our agenda will be introduction to Inc. smart contract language, and we'll also developing a smart contract using Inc. And at the last, we are testing this smart contract. So first, what is a smart contract? Smart contract is just simply a program stored on blockchain that runs when predetermined conditions are met. And we'll using the word WebAssembly throughout this session. So what is it? It is a low-level assembly-like language with a compact binary format that runs with near native performance and provide language with low-level memory model such as C++ and Rust with a completion target so that they can run on the web. It's basically used to run the code on the web. So our first is, how does ink relate to substrate? Before we can talk about ink, we just need to clarify what substrate and its contract palette contract are. Substrate is a framework for building blockchain, which can be standalone blockchain or blockchain connected to Kusama or Polkadot as so-called parachain. Substrate contain a number of modules, which in substrate terminology are called pallets. And substrate comes with a set of pallets for many requirements model. A blockchain typically have staking, fungible tokens, non-fungible tokens, governance, etc. Substrate also ship with a module for smart contract like contract palette. We'll using this contract palette. If a parachain is developed in Substrate, it can easily add smart contract functionality by including this palette. And how does Ink come into play here? Ink is a programming language. Specifically, it is embedded domain specific language, is also EDSL. For the popular Rust programming language, this means that you can use all the normal Rust syntax plus some specifics that we add to make the language suitable for the smart contract world. The contract palette takes these Ink contract and execute them in a safe manner. So in short, with Ink, you can write smart contract in Rust for blockchain, build with substrate that includes the contract palette. Okay. Next is smart contract versus parachain. What is the difference between them? One of the first question we typically get when somebody learn about substrate, Polkadot or Kusama is when to develop parachain versus when to develop smart contract. The distinction here is that in context of Polkadot and Kusama, a parachain leaves a slot for a couple of months for up to 2 years. The ideal with lease is that the parachain get a fixed slot for executing its business logic and can persist its modified state in a block. In substrate terminology, this state transition function is called the change runtime. The distinction to other ecosystem here is that in context of Polkadot, parachain and smart contract exist at a different layer of the stack. Smart contracts sit on the top of parachain. Parachain would usually be described as layer 1 blockchain, except for that they don't have to build their own security and are pre-upgradable and interoperable. It is noteworthy that a parachain state transition function doesn't get further validated It is up to parachain how it utilize its slot time. Once a parachain secure a slot by bonding token, the slot is essentially prepaid with no essential fee required for executing the chain business logic. This means the parachain can build its own world. For example, it can decide on how transaction fees are charged or even if transaction fees are charged at all. These options are crucial when building new or more user-friendly business model. Other distinguished factor between parachain that we observe in the wild are difference in how the chain governance or crypto economics work. There are some constraint on how the parachain can build its world though. Like physics in real world, it has to adhere to certain ground rules. For Polkadot and Kusama, that's for example the consensus algorithm for the relay chains to communicate with the parachain. For those ground rules, the advantage of Polkadot and Kusama emerge. Advantage like the aforementioned mentioned shared security, cross-chain communication, or guaranteed execution slot time. Like for smart contract on the other hand, an existing parachain has to include the contract palette for user to deploy smart contract. The deployed smart contract is always untrusted code. Anyone has that token of the chain can upload a smart contract without requiring permission. Smart contract allow permissionless deployment of untrusted program on a blockchain. The contract palette has to assume that these programs are adversible. It has to put a number of safety pillars in place to ensure that the contract cannot, example, stall the chain or cause state corruption of other contracts. For the contract palette, those safety pillars include mechanism like gas metering or deposit of storing data on chain. To restate this important distinction, developing a parachain runtime is different from developing a smart contract. A smart contract sits on top of parachain. The trade-off is that with a parachain, one has a freedom to decide all the rules that make up the parachain. With a smart contract, one is considered by what the chain allow and the safety pillars that necessary have to be in place. A smart contract, on the other hand, has less friction for developing and deploying it. Developer don't have to don't have think to about governance, crypto economics, etc. One just need a few token and can go on their merry way deploying a smart contract. It is as simple as that. If we see this, as we go into the ink, the development is easy. And if we go to the parachain, the technical freedom is more. Okay. Now next is how does the contract palette works? We intentionally design a contract palette in a way that it is decoupled from the language used to write smart contract. The palette is only the execution environment and it take WebAssembly file as input. Smart contract for this palette have to be compiled to the WebAssembly, or we can say WASM, target architecture. For contract developers, this means they can use Ink for writing smart contract, but can also decide on the other language. Right now, 3 languages to choose from the exist. First is Ink for Rust, Solidity, the Solang compiler for Solidity, and Ask for assembly script. It is not hard to add new language. They just need to be a compiler for the language down to WebAssembly. Then it is possible to implement the contract palette API. This API at the moment consists of about 15 to 15 to 20 functions for anything a smart contract may desire, like storage and cryptographic functionality, environmental information like block number, accessing to the function for getting random number, or to self terminate the contract, etc. Not all of those have to implemented in the language. The Inc. Hello World required just 6 API functions. The following schema depicts this relation. Let me see. Now we have a smart contract. This shows some APIs which have 15 to 20 functions here. And we have a language for developing a smart contract. And this WebAssembly bytecode is not just our smart contract. This smart contract use the APIs from the palette contract, and we can use it in our chain. Okay. Why include the contract palette on parachain? There are a couple use case of including smart contract functionality on a parachain. We distinguish three big one. First is smart contract as first class citizen. The most obvious use case is a parachain which provides smart contract as a first class citizen, meaning smart contract are the central value position of the chain. Those chains typically take the off the shell contract palette and create some additional innovation on the top of it. Example of this are Ester, Fala, Alpha Zero, and is T3RN. Like Ester build a layer on top of contract palette so that contract developer can earn a passive income whenever their contract are being used, like that. Second use case is smart contract as second class citizen. There is another not so obvious use case for the contract palette, smart contract as second class citizen on an existing chain. By this, we mean that a central value proposition of the chain has nothing to do with smart contract, but it still includes them as an add-on. Like they provide an API called chain extension with which a parachain can expose certain part of its business logic to the smart contract developer. Through this, smart contract developer can utilize the business logic primitive of the chain to build a new application on the top of it. Think of example of decentralized exchange blockchain. Like this chain would in simplest form have an order book to place bid and ask. There is no need for taking untrusted turning complete program from the outside. The parachain could decide to expose the order book into smart contract though, giving external developers the option of building new applications that utilize the order book. For example, to upload trading algorithm as a smart contract to the chain. Smart contract here are an opportunity to help increase user engagement, and the billing for utilizing the chain comes already built in with the palette. User have to pay gas fees for the execution of the smart contract. Now the third use case is smart contract as the first step into the Polkadot or Kusama. Third big use case of smart contract is to prototype an idea as a proof of concept. Smart contract before leasing a dedicated parachain slot on Polkadot or Kusama. The time to develop a smart contract and deploying it is shorter than the onboarding story for parachain. One can deploy a proof of concept smart contract first, see if it gain traction and the idea hold up to the real world. Only subsequently, once there is a need, for example, cheap transaction fees more efficient execution, or governance mechanism for the community. The smart contract could be migrated to the dedicated parachain runtime with its own slot. In contract and substrate runtime are both written in Rust and share similar primitives. This enables a clear path for a project to graduate from a smart contract to its own runtime. Developers can reuse large part of their code, their test, as well as front end and client code. Okay, a simple ink smart contract. This is the simple code. By default, we are giving this code. Okay, in this, ink is really just Rust that our overachieving goal. We aim to be minimally invasive, enabling developers to use everything that they also can use for normal Rust ID, like cargo FMT. It's for formatting the code. Cargo Clippy, this is used to find the anonymous line, like code snippets, the create ecosystem, etc. In the in this picture, you can see a simple ink contract. This contract here hold one boolean value in its storage here. Once the contract is created, it sets the boolean to true. The contract exposed two function. One is one to read the current value of the boolean, which is fn get, and one to switch the value to its opposite boolean value, that is flip. It basically flip the value to true to false and false to true. And whenever we want to get the value, we can get it by this function. It's pretty much a simple function. The colored line are ink specific annotation in the code. The rest is just normal Rust syntax. These annotations abstract away from what need to be happen under the hood in order to make the program compatible to be executed on chain. Also in this thing, let me just start the setup part. In setup, I think if you are working with a substrate, this is also been installed in your system. If not, you can go here and install it by running this command. Rest will install. I have already in my system. Then ink CLI, the first tool we need to install is cargo contract, a CLI tool for helping setting up and managing WebAssembly smart contract. Now then you need to install the binary package. You can install it by clicking on this, which is this is used to optimize the WebAssembly bytecode of the contract. Also, if you have an old version in your distributed package manager, you can download a binary release from here. Here you can download accordingly, Mac OS or Linux or Windows. Okay, after you have installed this, you need to install the contract package. I have already installed in our system because it takes so much time. To save that time, I've already installed it. You need to just copy it and paste it in your command. That's it. It will automatically install. This is used to ensure that you are on updated to the most recent contract cargo contract version. Also, you can use cargo contract help to start exploring the command made available for you. Also, two dependencies are to be needed to link the ink contract. This is done to warn user about using example API in a way that could lead to the security issue. For that, you need to copy this command and run it. Okay. Okay. For substrate framework prerequisite, if you have worked with substrate, then no need to do, just copy this and run this command in the terminal. Otherwise, you need to follow this link. Here, you need to go to a building phase, quick start there. Okay. After installing it, you need to copy this and run it in your terminal. Then you need to install the substrate smart contract node. For that, you just need to run this command. This will take around 5 to 10 minutes. After that, your smart contract is installed. Now we can create our project by using this command. I have already created it. In this, you will get the two files, lib.rs and cargo.toml. Okay, this is the contract source code and this is the rush dependencies. And this lib.rs, by default, it contains a code for, let me open this flavor. It contains by default the code which I have shown you in the doc. Like it has a struct of value which contains a boolean, and it has two main functions, which is flip or get. Whenever we call the get, it returns the value that is true or false, and whenever we want to flip this value, we can flip it. These two functions will use at the time of deploying our smart contract. By default, if we want to set the value, then by default it will set as false. Otherwise, we can set as our need. If we want to set true, we can do it. And these are the two test cases for it: default work and it work. Okay, for testing, we just need to run this, and the test case is running. What in test case is there? First is default work. We will not setting the value to be true or false. It just automatically set, and we are checking if it is false. If it is false, then the test case is true. Otherwise, it's false. So we have already seen that by default, it will set the value to be false, and we can test it by one simple that it works. We can will set the value to be false, and we'll flip it. Then we can check it. We after flipping, that should be true. And now this is working perfectly fine. Okay. After this, you can compile your contract. For compiling, you need this command, and go to the flipper directory and then use this command. It compile it in 5 steps. Like it uh, optimize the code. It compile shorten the code to the very limited lines. Also, after compiling it, it creates 3 files like these. What these 3 files are: .contract file. It is a JSON file that contains the contract's WebAssembly blob in hex encoding plus the contract metadata. And what metadata.json? It is a JSON file that contains just the contract metadata without the WebAssembly blob. And this file contains the contract WebAssembly blob. Okay. This file describe, we can see the metadata.json. Like we have types, storage, spec, types provide the custom data types used throughout the rest of the JSON. We can see here, and we can also see in our code here. This is the type. We have a primitive type, which is Boolean. And we have also the storage, define all the storage item managed by the contract and how it's ultimately access them. Where we have storage here. We have the storage. In this, we have only one name. And we have also a spec which stores information about the callable functions like constructor or message a user can tell to interact with the contract. It is also helpful information like events that are emitted by contract or any other doc. Spec, where we have spec. Here this is the spec. We have the argument and we have the document. Like we can initialize the value. We have also again an argument. By default, it will set as false. Yeah, if you look closely at the constructor and message, you will notice a selector which contains a 4-byte hash of the function name and is used to route our contract call to the correct function. Here, this is our selector. You can see here and here. Okay. Now we can run our command. For running our command, this command should be used. Okay, now we can deploy it. This is the contract UI where we can test our contract. By default, it is set to the Rococo contract, you just need to change it to the local, and then if you have choose local, then we can deploy it. For deploying, upload a new contract, we can select anything like Alice or Bob. We can choose any. We can select the dot contract file. This is our contract. We just select it and click next. Yeah, here by default it is set to be false, and we can set it to next. Now see in this part, if we get the value, now the value is false. If we want to change it, we can flip call contract, and now get the value is changed. It's a very simple function to flip the boolean value to true to false and false to true. We can again do this. We can get it. Yeah, this is it. We can also, like I have also already tell you about this function. We set the initial value as false when we initialize the contract, and for flip function, it just toggle the value true to false and false to true. Okay, what we can do one more. We can develop one more contract in this and test it. For that, like we can develop for incrementer, which increments the value by one or whatever we need. For that, just start. Now we use a macro for contract. Inc contract module this. Again use the macro for storage. Storage, and we make a struct. And now we need to implement this struct. Make the constructor pass the argument set the value by this init value. and we can again make a constructor for default. Okay. Constructor subfn default. In this we have nothing, no argument. For default we can this default is 0. Now we use the macro for message. What function? First function is to increase. It should be mutable. And by what value we need to increase this value? Self value. By. Again, we need a message macro for getting this value. Message by 32, we return the self dot value. Okay, our incremental is pretty much over. Just need to add some test cases. CEP. Use the ink for test. We are checking here is the default should work. Incremental new. Now this value should be 0. So we are checking here is contract dot get. This should be 0. Write one more test and it works. It should be immutable. we set the value to be 42 and then check contract.get should be 42, and if we increase by, let's say, 5, contract.get 42 plus 5, 47, it should be 47. Okay, let's say we can also again increase this by minus 50. Let's say what will happen. Result equal okay, I have contract and now this should be minus 3 and we can check it. For checking for testing we have one command creating this. There is a message, it's called contract mode incrementer. What will happen? Okay, the spelling is mistake. Check. It's showing error. The storage is correct. Let's close it. Still showing error. I think I need to make a new and paste it here. Middle. for making a new open. Oh yeah, where this flipper. I need this. Let's open the implementer. You can see here. Slightly. It's working fine. You can build it. Compile your code by using this command. Okay, this will create 3 files in target, in ink, incremental.wasm, metadata.json, and incremental.contact. Contract. Let's just check it by deploying this. For deploying, just need to go there, refresh it. Okay, we need to run this first. For running, we need this command. This is the flipper. I need to paste this in. Start this. Can delete this contract. And again deploy. Incremental target ink incremental.contract. Next, we can put any value here. By default, it is 0. We can let it be. Okay, we can fetch the value. The value is 0. We can increase by 5. Now we can check the value is 5. If we want to let's say -3. It's not typing here. Okay. 7. Yeah. Both contracts are working fine. So this is the main thing which I want to convey today. Mm, If anyone having any doubt, you can ask. How can this be? Hello, Dhruv. Okay, one more thing. Share. There is a quiz link I'm sending you. Shorten, copy. Guys, please fill it. And anyone can confirm me is form is opening or not. We need to learn ink solidity, rust, and one assembly language. No, you do not need to. Yeah, I'll have to provide this in Discord. Like I have already said that ink is very similar to the rust. It's rust, but just extra functionality is there. Nothing. Where is the Google Form link? Okay, I have pasted in the webinar chat. Are you able to access it or? Let me. Just a minute. Just a minute. Where need I to put this? Host and panelized event host. Wait a minute. I'll just confirm it when I need to put this link.
Yes, Deepak, the form has been filled. It's like,
Actually, I need to put a link. Where do I need to put this? I have already pasted in the webinar chat.
so since you're a panelist, I think you'll have the chat box access. No, you've posted that, right? Okay.
I have pasted in chat, but
So, okay, just share it with everyone. I think you shared it only with host and panelist. So I think when you send the message, there is a tab above, right, where you can send it to.
I have a two option: host and panelized and event media.
Oh, you don't have an option to message.
Yeah, I don't have.
I'll just post it for you. One second.
Actually, we missed yesterday quiz. Can we paste it here?
Yeah, sure. You can repeat the same process. Just I think you're not able to send messages to everyone.
Yeah, yeah.
You can send it here. I'll share it on the everyone group tab.
This is the link for yesterday. I have pasted in the chat box. You can uh, give it to everyone.
Just a minute, sharing this also. Okay. We've shared both days Google Forms now in the chat. For everyone who needs to use a link for references, you can check the chat box.
This document I'll share in the Discord. Also some reference link. Okay, Dhruv, this is it. I have completed my.
Okay, so we're good to conclude.
Yeah.
Okay, so thank you everyone for joining. Thanks Deepak for taking this session. We appreciate it. So I hope you guys have taken note of the links that have been shared with you and fill this in time. Apart from that, sure, we'll see you soon with another session. Okay, thank you for joining.
Yeah. Thank you all. Bye bye.